Hello again, and here is a quick video tutorial on how to use the Tracker program. And the Tracker program is a tool for doing video analysis. So you can take a video of anything moving, whether it's from a video camera or your cell phone, and you can import the video into this program, and you can use pixel counting and the time steps of each frame to try to figure out things about the motion of the object. It's kind of neat technology, and it's on all the lab computers, and it's on the desktop. It's an icon called Tracker. It kind of looks like a purple tracking ball or something. So the window that you have here is what should happen when you load up Tracker. It will actually won't have a video in it yet. I've already loaded in this video, and you can see the video. You can upload a video either by going to File, and you'll see that there's an import for video, or you can go over to the Video tab, and I believe if you don't have a video loaded, there's an option to import from there too. So either one should work. Or I'm pretty sure you could even just drag a video from your desktop and drop it into this area, and it will load it in. And there might be an error message or something that says the frames aren't coherent. If that happens, let me know, and we'll try to find a way around it. But it shouldn't be that big a deal. Anyway, there's a video in here now. And once you have a video, there's a few steps to doing the analysis. So after importing the video, you have to move your frame forward to start. So I'm going to show you an example of that. There's controls here that can move the whole video forward frame by frame. So this red thing here is 1. It means that you're on the first frame. So you could step forward to the next frame, and you'll see actually the frame counts are over here. You're on frame 2 now. This is just the step. So how many frames forward each one of these will do. So I'll go back to 0. Look over here on the left. You'll see 0, 0, 0. If I click to the right, you'll get to frame 1, and then frame 2, and then frame 3. So this is how many frames you'll go forward or back using these controls, and this is what frame you're on. And I'm actually going to go to, okay, we'll start at frame 0. And frame 0 is when the person's going to let go of this car. And it might be that you take a video where the object is actually not moving until somewhere later on in the video, and you could set that with either moving forward to this, or actually you could even take these little things here and then drag them to wherever you want to analyze your video. This would be the start, and then this one over here would be the finish. But I'm just going to put these all the way left and right. So you could also set the time to 0. We're actually starting with the 0th frame, but if you click on here and there's a selection for set time, you can set the time for whatever frame to time 0, because events don't necessarily start happening when you begin filming. Sometimes they start happening in the middle of filming. So you can set the time to 0. The next step in this whole process is to make an axis system. There's one kind of drawn on these whiteboards back here in this physics lab. We're going to create an electronic one so the computer knows what we think is the axis along which the car is moving. And there's this axis thing right here. If you click on it, you will get a purple axis system that you can drag around. Go right to the middle, like the very middle, and you click and hold, and you can drag this axis system wherever you'd like. And if you want the car to start from the axis, you have to take the origin and put it wherever you'd like to make the 0th position of the car located. If you want to count the position of the car by looking at the front wheel or the rear wheel or like the front bumper here, that's where you would drop it. So I'm going to drop it on the front wheel. It's kind of easy to see because it's kind of round and silver here. So I'm going to make that the position of the car, and the car then will begin its motion at a position of 0 on the x-axis and 0 on the y-axis. Now the car is just going to move off to the right along this x-axis. We don't really expect any motion along the y-axis. So something else you can do is to twist your axis system so you make sure that the car is actually only traveling on one axis. This simplifies the analysis. There are things that actually move both up, down, and left, right at the same time. This just doesn't happen to be one of them. So I'm going to orient this ever so slightly to see if the car travels along this direction, and I'm going to press play. And I'm going to watch to see if that wheel actually stays along that purple line the whole time. And if it doesn't, I can adjust ever so slightly to make sure that it does. And as it's moving along, it looks like it's rising up ever so slightly. So I'm going to go back to here, and I'm going to tilt my axis just a little bit so that the purple goes through the silver of these 2 wheel hubs over here. And now I know I have it aligned so that the straight motion of the car is also being analyzed by this straight line on my axis system. The next step is to actually set a known distance. So what the computer actually does to figure out where you are, it takes a look at pixels. It's looking at little bits of color on the screen. It doesn't know what a meter or a foot is, so you have to tell it what it is. And fortunately, in this video, someone marked out different positions on here, and these are in meters. So 1 meter is here, 0 meters is over here. If you go over to create, I think over here too, this works as well. But if you go to create, you can create a calibration tool called a calibration stick. And it's just a stick that defines a distance. By default, it says 100.0 in here, and you can move this stick wherever. I'm going to start it over here at 0, and I'm going to grab the other end, and I'm going to drag it over to 1, and center it and line it up as best as I can on here. And then if you click on the number, you can define what that length is in the real world. And I'm going to make it 1.0 and then press enter. So now the computer knows anything that moves from this spot over to this spot has moved a meter within this whole screen. Okay, this is the rewind button. That takes me right back to the beginning. Once I've set a distance and calibrated that distance off, we have to define the thing that's going to move. And we're going to do this manually. There's an option to have the computer auto-follow something, and it's kind of a pain. So we're going to follow it manually by going back to create, and we're going to create a point mass. A point mass is literally defining the spot on the car that's going to act like our point, which is moving. So point mass, and then to define that point mass, I believe it's shift, and then you click wherever you want to define the point mass of the object that's moving. So I'm going to click, and I'm going to click on that very front wheel spot right there. So that has defined a position of 0 and where the car is going to be starting. Now, when I did that, you may notice that time went ahead. Like it automatically jumped to the next frame. And if you look over here, at time 0, a data point has been plotted at a position of 0 as well. Now, I'm going to go back to this frame over here because what I'd like to do is I'd like the step size for each of these to be something more than just 1 frame because it's a very small period of time. It's going to take me forever to mark all the positions of the car all the way down if we're going every 0.067 seconds. So I'm going to have it go forward every 10 frames. So if I go forward every 10 frames, our 0th position is already there. I'm going to click ahead, and now we're 10 frames further on. The car is over to the right. I'm going to hold down the shift button. So the shift button gets held, the cursor turns into a square, and I'm going to center up that image again of the wheel, and I'm going to click. And I've now defined a second point. The second point is 10 frames ahead, which looks like a time of about 0.36 seconds or something like that. And a new position has been defined up here too. And we've gone ahead 10 more frames automatically. The program just did that for you. So now I'm just going to keep going ahead. I'm going to hold down the shift button. I'm going to put the cursor on the wheel here and click. The car is 10 frames ahead now. Put the wheel here and click. Click. And I'm going to keep going until I run out of video to analyze. And you'll notice on the right, we're starting to fill in a data table and a graph. And that takes me to the end. On my 8th point, you see all the points are here now. Here's 0, 1, 2, 3, 4, 5, and so on. And you might actually notice that for every 10 frames, the object seems to travel a greater distance. And the graph here has a very nice shape that you might recognize as a parabola. And then you have a data table here with all the different times and all the different positions of the object. Another interesting feature of this is you could hypothetically go up here and click on the axis and say, I don't want position. I'd like to see what happens to the velocity along that x-axis as time goes on. And you get a sketch of what's happening with the velocity as time goes on over here. That's a really powerful program for analyzing motion, and it's available for any video that you take in our laboratory. And it's something that we'll be using during the year to study motions of objects. Yeah, I hope that helps. Bye-bye.